simplifying your architecture.
I think you can check from
Redis
the
might be a
phone.
fit
I'm trying to fix the
for these
audio.
use cases. How many of you have heard about Redis being used as, for example, as a full text search?
Can we put this
Previously.
over there?
Can
No, yeah, that's
take
all
it.
some of the part, and we will see that in action
Tell
today.
me the framework.
Okay, so next is Redis as a multimodal database. If you are using Redis as a string, only string as data structures, and if the answer is yes, then in my opinion you are underusing Redis, because Redis is way more powerful than just storing data as a simple string. You can store data into Redis is multiple ways. And here are some of the core data structures. You can store data, as I mentioned, Redis as a strings, that's how you probably know it, either as a cache or maybe as a, like user profile and so on. For example, Redis hashes, which is multiple fields and values data structures, more like a relational database you will have, which is very efficient to retrieve individual fields in a multi-field data structures. List, for example, you can implement the list use case for that one, or implementing a task queue for that one. Sets, which is nothing but a collection of values. So it's more like an array. So where you can, for example, if you've been looking for a set of users that has visited your website, so you can store that information into a set. Sorted sets, again, it's an ordered collection of values, very similar to sets, where you assign a score with the individual and the data is sorted. It gives you to retrieve the data based on the sorted information. And the use cases for sorted sets is if you are looking to implement a, let's say, leaderboard ranking, or if you are looking to implement as a fraud use case, so where you can maybe, based on set rules, and you can say, okay, rate limiting, for example, if you want to protect your APIs and you want to ensure that not more than 100 users should be hitting your APIs in the last 1 hour or so. So sorted sets is a very optimal data structure for that one. Redis stream, as I highlighted, is for more like Kafka kind of thing. But Redis is beyond these basic data structures as well. So there are some advanced data structure as well, we call Redis modules, which is only available again on enterprise. If you are using AWS Elastic Cache, or if you are using GCP Memory Store, it sounds like salesy, but it is more for information that this is not available in Elastic Cache or GCP Memory Store. So if Redis Search provide you a full texture, secondary indexing, and filtering on your data in Redis on hash or as a JSON structure. So for example, you may have user profile or product catalog. You store that data into a hash, which is multiple fields and values, and then you can apply a filters or full text search on that data structures. Similar to that one, Redis JSON, which allows you to store, retrieve, or search data into native JSON document into Redis. Time series, very optimal for any timestamp data structures, maybe for IoT sensors, or if you've been looking to monitor your CPU utilization real time. So this time series is very optimal data structure for that one. Redis Bloom, it's a probabilistic data structure, very, very popular for any fraud use cases. For example, you may have some rule-based engines, so where you can store that information. So why it's a probabilistic data structure? Because at times you may get false positives. So it has to be a proper use case for that one. So when I say fraud use case, and you may have your rules. For example, a user X didn't make a transactions from this and this locations from this and this amount. So just imagine doing that for every single payment. If you want to do it, so that has to be real time, and that database has to handle hundreds and thousands of requests per second. So that information can be stored into Redis Bloom in that case. So some of our customers been using Bloom for messaging use case as well. For example, they want to ensure that they don't send duplicate messages to users. One of our customers been using Bloom is to ensure that they don't use a vulnerable password. So what they did is they store all the billions of vulnerable password into Bloom, and every time user try to create a new password, it's an identity service. First thing they do is they check in Bloom filter, is it one of the vulnerable passwords, and then only this. So it's like if you have an expensive operation, before doing that expensive operation, if you have to find the existence, use Bloom filter. So you can optimize your architecture based on that. And here is a reference architecture actually, where Redis is being used as a primary database. This is being used similar architecture from one of our customers. So they have data sitting into silos into different records. I'm sure every day you might be coming across to these architectures where data is being sitting into silos, the application built on top of the data is slow. How can I marry that data together and store into a fast data server layer like Redis and serve the APIs from there? So in this case, they have been using Redis as a distributed queue. Sorted set is the data structures for the distributed queue. They are saving the state of those tasks. When they are processing any task, they are saving the state of those tasks into Redis JSON. In between, if you have to, this is a, first of all, this is a microservice-based applications being written in .NET, and yeah, so and they can search as well those task queue. What they are also doing is they using Redis as the primary database and syncing the data from and comparing it with their original database as well, and also publishing it using Redis stream for other microservices. Any questions on this? Okay, so here is an example quickly. So the first one, first screenshot is how you can use Redis as implementing a priority queue using sorted sets. You have your different members. Still, if you see that as a key, but the member and they assign you this score. So you can query that information based on those values, and that's how you decide. So this is how you implement the priority queue. And another microservice that comes and that try to process that task and do things with it, and it saves the state of the task into Redis into a native JSON document. So on the right side, that data is stored into Redis as a JSON document. One of the questions asked in Redis is how does it can handle atomicity, like multiple commands. So Redis can do that. There are multiple ways of doing it. So in this example, you can put that multiple commands in a block of multi and exit, but there are other ways of doing as well, like Lua scripts and so on. And so this is how you can query the task or search engine works. So for example, if you already have your task state stored into Redis as a JSON document, on the left hand side, you create secondary indexing where you give the key patterns and you can create different type of indexing. As a numeric, you can perform the range queries. As a tag, you can do an exact match, or as a text where you can do full text search. So individual fields here, in this case, for example, for the kind field, it's a tag. Some other fields, for example, number of attempts, that's a numeric. And history region, that's as a text. So based on these fields, you can query that information based on these indexing. So for example, the search queries on the right hand side is find me all the tasks where the status is completed, or find the history has a status of failed entry and so on. So you don't have to go outside of Redis to implement this application. So using the sorted sets, you implemented a priority queue. Using the JSON, you store data into Redis into native JSON document. And using Redis search, you've been able to create secondary indexing and query that information out of Redis. Okay, so let's do a quick demo and see this in action. A little bit more. So what I'm going to show you in my demo is first, you know, of all for us very popular, Redis as a cache, where we initially we will retrieve data from a disk-based database which is slow, and using Redis we will make it fast. And then we will solve some other caching challenges. If you've been using caching, one of the number one challenge for the caching is how can you keep your cache in sync with your source database. So I'm going to talk about that as well. So we have a product for that called Redis Data Integration that can seamlessly sync your data from your source database like Postgres, Mongo, or any other database to target Redis without writing any code. What we're going to do is how you can leverage Redis complex data structures, in this case, JSON, hash, etc., to improve the overall performance of your application. And then we're going to search products with Redis search. Then Redis also has a big role to play for Redis for AI for different use cases, as Redis as a semantic cache, as a semantic route, and agentic memory. I'm not sure if you're familiar about these terms, but I will briefly talk about these concepts, because if you are looking to build any AI chat course, you might be hearing these different use cases day in, day out, I guess. Alright, so, okay, this is going to be a bit challenging, but let's see. Alright, so what I'm going to do is first I'm going to, so this is an e-commerce website where it's being, I'm on the left hand side, I'm going to enable Redis feature one by one, and then we will see how it solves different business use cases, and it also solves some developer use cases and reduce development complexity. So the first use case is this website. I'm going to do is I'm going to load data. The data is there on relational database, on a disk-based database, and we look at the data latency for this. So if you see, the caching is off, and the data latency might not be visible to you, so it's like around 3 seconds. So once I enable the caching part, and let's see the data latency. So if you see, the data latency has been improved significantly, almost from 3 seconds to 0.02 seconds. Because what it's doing now, rather than reading the data from the disk-based database, it's fetching the information from Redis in the cache in memory. This is what you know for us. There is a slow app, we store the data into cache in memory, and we make the app fast. All good, happy days. But this is where most of our competitors, if you are using Elastic Cache, this is where they end. This is what pretty much they can do. But with enterprise, I will show you how we can do different things. Okay, so one of the things I want to show you here is, so you see here, the data is being stored into Redis as a string, even though the original data was as a JSON, but developer has to serialize it. For example, if you want to fetch a particular field, then you have to deserialize it, get that information, which is always a tedious task. So what I'm going to do now is I'm going to enable, so on this my website, I want to fetch inventory data. So there is a product inventory, product catalog. That data is stored into Redis as a JSON. So I want to fetch that information as well. I want to give better customer experience. I want to give them more information. So how are you going to do that? This database may not be able to handle those many transactions in real time. So once I enable this data enrichment, and so all of a sudden you see here, so you see we've been able to provide the product count as well. There's more descriptions, the better images, so all now we've been able to fetch, and reason why we have been able to do it is because now we bringing the complex data structures, we are storing complex data structures into Redis as a JSON, for example, in this case. So you see here, like the data is being stored into Redis as a JSON with different formats. I can now retrieve the individual fields. I don't have to retrieve the entire JSON, deserialize and serialize it, which is only available only in Redis Enterprise. There are workarounds. You can still store that as a string, work it out in your application. But that is tedious and probably going to slow down your applications. There are better ways to do it, and just within Redis. So another one is, all right. So, and then similarly we have hash as well, which is more like a relational database. You see multiple fields and values as well. So now the other challenge is, okay, so this is an inventory and this is an e-commerce website. You might be having Friday sales and everything, so your inventory would be continuously updating. So how are you going to ensure that any update in the inventory can be reflected in real time on your website as well? How are you going to do that? So means you have to find a way or mechanism to keep your data in sync in your cache from your source database, whether it's Oracle or wherever your inventory is being updated. So, which is all normally a tedious task, and you don't want your customers or user to read the stale information. So, how Redis solve this problem? We solve this problem with, I would call it Redis data integration. So, for example, RDI. So, you may have your data in silos. In your source database. So, you don't have to worry about building your own CDC pipeline, change data capture pipeline, to keep your data in sync with your cache from your source database. The RDI do it without writing any code, and I will show you how. Okay, so for example, if I go and edit the inventory, I take one of the products here, for example, pita, women, browns, and let's say I change the inventory from 50 to 0. So I update the inventory in real time. We would see that inventory is being updated here. All of a sudden you see the product is out of stock. So you giving that customer experience to your user now. So they always been getting latest and up-to-date inventory. Probably it would have not been possible if you would have been using just this case database. There has always been lag. We see that always customers, we have many customers using this feature. And why it has been possible? because of RDI, which can keep your cache in sync with your source database in the real time without writing any code. So, and what you can do even more now, like for example, like as the data is there in Redis in a complex data structure, any user experience, what they've been doing it, you can capture all that into Redis. Now the last use case I want to do is, for example, let's say you want to do a search as well. So customers come into your website and they want to do real-time search. So Redis, as I mentioned, has a search engine as well that comes in autocomplete and all those features as well, apart from secondary indexing. So if you see, it's been coming up for giving me suggestions, auto-suggestions, auto-completions. For example, I look for sandals, and all of a sudden it's giving me all sandals. And this all has been, the search is being done through Redis. These product catalog, that information is stored into Redis, and I'm performing the search. I've shown you an example in my previous slide how you create secondary indexing and query that data. And this all has been, only database I've been using here is Redis. Okay, so this has been the first part. Now, okay, this has been the legacy things. You can do the search, you can do the, how about AI? So this e-commerce website, they would like to provide a AI assistant chatbot to their users. So what they want to look is, they want to provide an AI assistant. So let me enable it. So you see here, like I have a chatbot now, and I'm going to enable semantic caching. I'll talk about it. So what it's doing is this AI assistant chatbot. This is this chatbot is interacting with LLMs. Have you all heard about LLMs? So ChatGPT is based on OpenAI LLM, for example. So this chatbot as well is based on OpenAI. So what it's doing is I can interact with this e-commerce website in a natural language. So I can say, hey, find me some sunglasses. And I would be enabling semantic cache, and I will explain what is a semantic cache is. So first thing, as I open this chatbot, it's interacting with LLM, and it is giving me, hey, welcome to this one. So this is all been on the left hand side. You can see that there has been one LLM request. How many of you are aware that every time you call OpenAIs, there are, and it generates tokens, there are money you have to pay for those APIs, right? So you want to minimize those costs, and semantic cache is the way. Because in real world, we have seen, based on different research, 70% of the questions are similar. So you don't have to hit the APIs for the similar questions. They can be saved, those questions and their responses can be saved into Redis in an embedding and respond it from there. That way, it will give you a better user experience, and it will reduce your AI cost for your product quite significantly using the semantic caching. So first, because there is no data, I will ask a question. I want to find classes. Okay, so it's considering styles, so it interacted with the chatbot, but the more important part is on the left hand side there has been 3 calls to LLM. So with this one, I have interacted with my LLM 3 times, and obviously I can click, and then it has generated a response, and I click on this find the sunglasses. And by the way, this all search, again the image based search, is also being done into Redis as a vector embedding search. If you've been familiar about a semantic search, so this data is, those images being stored into Redis and performing a vector embedding search. So we call the LLM API 3 times, the response time is close to 1 millisecond. So let's say I close this, okay, so I change the user. So for example, instead of Jonathan, I have Alex coming up now. And Alex asks the similar questions. It doesn't have to be the same. Find sunglasses. So Alex is also looking for sunglasses. So if you see, the LLM request reduced from 3 to 1, and there has been a cache hit because the previous questions and its response being saved in Redis. So you are getting consistent answers and the cache is being hit lesser. And the response time is way faster. This time the response is around 0.2 milliseconds. If I click on this one, then it gives me the sunglasses again. So, so this is my semantic cache architecture. So the user, they ask the questions, do you have any block of colored vans, or I am looking for a pair of block vans. So they are the similar questions. If the questions been asked previously, that response would have been saved in a cache. Redis is known for cache. That questions and response being saved as questions is saved as an embedding, so that you can do a vector similarity search and the response will be saved as it is. And if it's a new questions, then only it would be routed to LLM. But now let's say as a next question, I want to check with it, okay, I asked some random question, say, how, this is an e-commerce website, how did John Wick end? So as I mentioned, because again these questions as well, they are hitting it's going to hit the LLM APIs. There are, I'll talk about it, but it's going to hit the LLM APIs and generate a response from there. So it's kind of did an okay job and say, hey, I'm here for the fashion queries, and you please ask me, search for the fashion John Wick. So not a great user experience. You want your user to have better experience. So if you've been looking for that. So the way to do it is, in real world, you might not be dealing in one system, one LLM. You might be dealing with multiple LLMs, multiple systems. And to deal with those multiple systems, you have to find a way to route your queries to right system. Whether it need to go to LLM1, whether it need to go to LLM-B, or whether it need to be query a in-house database and so on. So how are you going to do that? So this is where comes this feature called semantic routing. So semantic routing is nothing but it's an intelligence that you add on top of your AI assistant. So semantic routing is kind of having those rules stored into Redis. Based on that, it decides which layer it needs to go. Again, that being all done into Redis. So again, I've been asked, and this time I'm also enabling my LLM memory as well. How many? So some of the limitations with those LLMs, they do not have any memory. So I interact with them today, I have my sessions. If I come and I close my sessions, I come again next day, they don't know what I asked from yesterday. So that is a limitation, and they are reactive in nature as well. That's another limitation. So how they overcome with this? So you want to store user session or user interaction in a database. So Redis is that database where you store their previous chat history so that you can provide a better experience. You can provide a summarization. They can start where they left yesterday. So, and I'll show you how we do that. Okay, so I go back to, let's say, this user Jonathan, and I say, hey, I open the chatbot again. And this time I have opened the semantic routing as well as LLM memory. So I'm going to ask some questions related to actually, then I'll use this user Alex, who is having an item, these event shoes in their product. Okay, I have 10 minutes, I think I have plenty time. So they already have a shoe in their cart, and I have closed the session, but I'm coming back again to say, hey, can you show me similar shoes? Okay, let's see. Edit. Now let's refresh. If you're interested in the product, let me know, you can find it. let me quickly show you the architecture for semantic routing. So the architecture, as I mentioned, is Redis become that AI layer on top of it. And if it is so you save the logic whether the questions need to be answered by LLM or it has to be answered from your internal database or different LLMs. So you have to have those questions retained. And by the way, if you are also looking to protect your API as well, for example, those LLMs, they don't have any role-based access control. So if you're providing a single interface, you want to save that logic somewhere so that you can ensure, okay, the right questions being routed to right system as well. So you can implement all that logic into Redis again. And as I have stored the LLM chat history as well this time, so I can get the better response time now actually. So for example, how far is from I'm not quite sure about the specific, but let me, okay. So this time we get better customer experience, not like last one just saying, okay, I don't know about John Wick, because what we did is we did semantic routing. So rather than it going to LLM, this response has been generated from the data being stored into Redis. So you can save those rules, etc. into Redis. Let's quickly talk about, let's pretty much cover these things. So yeah, if you've been looking to do all those use cases, advanced use cases for AI, then you probably need Redis for agentic memory or your short-term and long-term, and we will provide it. Now the important question is, do I need enterprise, and 10 reasons why you may need your Redis enterprise? Let's talk about that quickly. Is your OSS Redis is reliable? Is it highly available? Are you getting a single digit second failover? Do you need to persist your data on disk, the data you are writing in memory? If the answer is you are okay with open source, then yeah, you don't need enterprise. Do you need to deploy your Redis architecture in multiple regions? Means in active-active manner, multi-region DC, active-active manner, multi-residency. Open source can't do it. Elastic Cache cannot do this, memory store. No other Redis technology can provide active-active architecture where you can deploy it across two different clusters, two data centers, and can do read and write both clusters. This is based on CRDT technology, only available with Redis Enterprise. This is very important. This is one of the main reasons a lot of banks using Redis Enterprise. And due to this architecture, we get 5 nines of availability. Is your OSS Redis failed to scale to handle more data or throughput with low latency? We have seen. How many of you know that Redis open source is single thread? Or Redis is single thread actually, not even know. So if you're not aware, Redis is single thread, means you may have 10 or 20 or 30, 40 cores on your VMs, but it is just one core that will process your data. That is the limitations with open source. With enterprise, we have sharding concept where you can handle terabytes of data in one database and millions of read and write without any drop of latency. You would still get less than 1 millisecond of response time in enterprise for that. Is managing OSS Redis painful? Anytime you do scaling, anytime you do batching, do you experience any downtime? Is it a painful exercise for you? If not, then you probably don't need Redis Enterprise. Is your OSS Redis infrastructure is being used efficiently? So one of the limitations with any competitor like Elastic Cache, I was talking some of the folks here, that every time you need a Redis cluster, you have to spin separate different databases. So you may have, with Enterprise, you don't need to, so if you've been managing, we have something called multi-tenancy. Means you can have a one Redis Enterprise cluster on 3 VMs, and you can have tens of databases depending on the capacity just with VMs. So sometimes people say, hey, my open source is fine, but we have customers, they have been able to save money moving from open source to enterprise because of multi-tenancy, because they have saved thousands of dollars on infrastructure. So now I've got enough time. Okay, reason number 6. Sync my cache without writing any code. Do you have a requirement of syncing your cache with your source database without writing any code? You may have your data in Postgres, Oracle, Mongo. How can I keep that data in sync with Redis without writing any code? You need RDI for that one, which is again only available with Enterprise. That's the product we have as part of that. Cost-effective Redis. So available everywhere. Do you need to use Redis as a service on Redis Cloud, or do you want to use Redis self-managed but still get the support from us? That's again only with the Redis Enterprise. And Redis for AI use cases I mentioned, we have been integrating with different ecosystems like AI, Langcache, fastest vector database, simplified APIs using VectorDB. And obviously the most important part is you get the support from the creator of the Redis. So these are the main reasons in my opinion to use Enterprise. If the answer for all the questions is no, you probably don't need Enterprise. And this is an active architecture where you can deploy Redis Enterprise across 2 different regions or data centers. And this is based on the CRDP. For example, mobile app sessions, it would be a seamless session migration. If one data center goes down, user can be seamlessly migrated to another data center because any data you are writing in Redis here is being synced across the data centers by Redis itself. You don't have to worry about that. And how you can start, some of you who wants to learn about Redis, maybe take this. We have Redis universities. There are plenty of quick starts and so much materials out there, so you can check that out. And the lucky draw, the final thing. So take a photo of this and fill in the form. Everyone took? Okay, any questions?
Can you go back again?
Sorry, yeah. While you've been scanning it, any questions for the audience, please? No questions?
I'll just ask you the question and perhaps you
Yeah, sure.
Yeah, so my question is about...
Bro, you and this guy, now I use it a lot.
Yes, I mean that's the default for us, bro.
Using this.
That
is using your semantic caching and your full text search.
Yeah, so the question is, for semantic caching, can they bring their own embedding model to create an embedding for your text or images, vector embedding? Answer is yes, definitely. So Redis is flexible, so we are providing, so there are 2 ways you can use Redis semantic cache. Semantic cache as a service, so if you are using our offering on cloud, then you can use it as a service, and there also you have the flexibility to choose the model to create the embedding. And obviously you can bring your own embedding model to create the text as well. So Redis is being providing the facility to do the search based on your embedding. And it's a hybrid search.
What model is it? Redis something like default?
By default, we've been using OpenAI.
Can we use Redis Enterprise as the primary database, only database? I don't want Oracle, I don't want Postgres, I only use Redis as my primary database. Has any of your enterprise customers done that? And what we can take care of it on this scenario?
Sure. So the question is, can Redis Enterprise be used as primary and only database? The answer is yes. Obviously, it depends. 40% of our customers been using Redis as primary database. Lot of times, any configuration data, any lookups, that sort of data, they always store in Redis and use as primary database. The use case I have shared the reference architecture that's being used by the #1 retailer in Australia and using Redis as the only database. They still have system of record, but for their main application, that HR system application, and it has been there in production for last 5 years, and Redis has never gone down in last 5 years, or not being able to handle, or not being a scenario where it's not being able to handle any latency. Yeah, sir.
Just now, you show about the Redis data integrated philosophy, right?
Yeah.
The one. Okay, my question is, does that one is the OSS feature for the Redis one, or I can use that if I'm having Upstash? If let's say I'm using Upstash right now, so can I do that?
No, so the question is, can they use RDI, which is Redis Data Integration, the product that can keep your source database, Oracle, Mongo, etc., in sync with target Redis? Can it use the Upstash? No. Answer is no, so only with Enterprise itself. Yeah. Yeah, that was one of those 10 reasons. So, more questions?
We have 2 more questions.
Okay.
Is for Redis Enterprise, is there a way to handle schema evolution, like to keep your data content, data schema like consistent?
Yeah, good question. So is there a way to keep your schema consistent in Redis? So Redis is schema free. So because it's a key value database, the only
Think
schema
two.
you have is you design the key. So design your key is very, very important.
promote
So
it
that's
as
where
well,
you
no?
will be defining a key based on different rules. You need to see how you're going to query it, how you're going to scale it, and so on.
Let's make some prices for that kind of.
No, it's still the root of the product is same, like it's built on top of Redis, so the basic capability hasn't changed. It's a NoSQL key value database, and it's flexible. The key value is being designed to be flexible and schema free.
Amazon DynamoDB is becoming more expensive. Is there any pathways to migrate from that service to use cloud?
Yeah, so the question is there an easy path for to migrate from Amazon DynamoDB to Redis Cloud? Yeah, answer is yes. So we have many customers been using DynamoDB as a document store, and they've been like having hard time because the cost, especially being a server-side service, the cost can go up very high. So we can have separate conversations how that workload can be migrated to Redis Enterprise. Is it okay to take 2 more questions?
I'm just curious to know how does Redis Enterprise compares to Workday?
Yes. So you see in my demo, I have enabled Redis feature one by one, starting from simple cache to how you can enrich data, bring complex data structure with RDI and advanced use cases with AI. So Workday may be able to serve only your very first use case as a cache. All those features are not there in Workday. And I shared the difference between moving from OSS to enterprise. So Workday is nothing but it's still very much open source. Those enterprise grade features, a lot of customers move from Workday to enterprise because they find our enterprise more cost effective due to our multi-tenancy, where we can have multiple databases in single cluster. Some customers use it because they are having less, not good enough performance to handle their traffic. So there are multiple reasons that customers they move from Workday to Redis. We can have conversation on that. Sir.
I'm just curious about the full text search capability because I think most of us, my previous company actually use Elasticsearch instead of Redis. I just want to know how capable Redis is in terms of full text search.
So the question is how capable Redis full text search is compared to something like Elasticsearch. So the answer is probably Redis, in our experience, full text search might be able to serve 98% of search capability that probably we have in Elasticsearch. But the key difference is the ease of use. Obviously, you don't have to go outside of Redis, you can use. And then second, the more important one is the performance. The response time, the scale, and the throughput that Redis can handle compared to Elasticsearch is hundreds of times better. So we have benchmark available compared to Elasticsearch.
I have a question. Like, suppose now you given the example of e-commerce website, right? That is used for the Redis, like
So in case of we have a database as a share, which is having a transactional database. So if the transaction is coming or if withdrawal happen or something like the banking database, can we use the reading also there? Because the transaction sometimes get paid, sometimes get aborted or something happens. So in this case, the reading can be used.
The question is, if you are doing the dollar transfer, can you do the dollar transactions in Redis where it's critical and you can't absolutely? The answer is no. Yeah. So in that scenarios where you absolutely have this 100% strong consistency requirement and you're doing the actual dollar transfer, Redis might not use it. Yeah. Cool. Thank you. I just only.
So my question might be something. When doing RAG using Redis, is it possible? Is there a redundancy region if, for example, you cache the context system and can it be retrieved from a different database? Yeah, with Redis, if the current context is not present in the cache, can a different database be used as a redundant database to retrieve it?
Yeah, definitely. So the question is how Redis can be used as RAG and to retrieve different attributes. Is that a question? To retrieve different attributes. Yeah, of course. Yeah, you can refer to. So for RAG actually, so you can have the data from here. You can create the embedding and get the data from the Redis from there. Okay, so we have products for that ones as I mentioned like RDI that can send data from the database. But Redis is still a database to store your RAG information. You still require a model to create the embedding and store it. And to have an application. Redis we have some fallback library thank you guys, thanks for I have all the great questions. Thank you.
Thank you, Ahmed. That was really insightful. Thanks. So after this, we'll have a hiring update and followed by Zidane's topic. I'll pass it on to Siddharth to have discussion on the hiring update.
The wire down there.
First of all, thanks to Amit. That was a very informative session. Guys, before we move on to the next session, we'll do the hiring updates and lightning talks. So how that goes is, for the hiring updates, you just if you're hiring, if your team is hiring, you can raise your hand, we'll pass the mic, you can share the information, and maybe we can, people can reach out to you later on. So let's start with the hiring updates first. Is anyone hiring here? So we have DevOps, SRE, platform, developers in our audience. Anyone hiring? No one's hiring? You are hiring?
Let's go with hiring. Hello everybody, my career again. So yes, I'm always hiring. Both senior and junior, Terraform, AWS, Kubernetes. Yeah, so come to me. Now you get to tackle not just US problem, global problem.
Great. Thank you. Thanks.
Money line. Yeah. So yeah, come talk to me.
Thank you. Anyone else hiring? No one?
Hi everyone. So I'm Syaril. I'm for BU. BU is a digital bank. That provide banking line. So there's an opening under my team for basically investigation. My team is a tech team. It's a technology engineering and data. It's all. So basically full IT stuff there. So we have an opening for AI engineer because we basically is covering which is the AI box. So if anyone like super driven towards on the AI,
Thank you. Did Mo announce? I think. Yeah, announced already. Thank
Yeah,
you.
AirAsia is hiring. You can go to the carriers page in AirAsia and there are a couple of jobs you can apply.
Or if you want, you can reach out to Mo, he is out there. After this, or any one of us. Let's move to the lightning talks. In this, we just go through any technical updates, any information, any tech-related news you guys want to share with everyone. So just feel free to raise your hand, share information. Anyone wants to share anything? I'll start first. So recently we started working again. I started working again on GitLab, and I discovered GitLab has introduced something new, which is called components. Are you guys familiar with components? So components is plug-and-play templates that you can put. So you build a part of your pipeline, and then you publish it as a component. You put in variables, and then it just configures according to your needs. So they have a public library. Even if you are not interested in publishing any components, maybe you can just go through the public library and see if any of the components interest you. Sorry? It's exactly a template. It's exactly a template, but earlier we used to have variables. Right? Yeah, but now they replace variables or added inputs also, apart from variables. So inputs, when you add inputs, it clearly defines you when you publish your components that these are all the specs available that are configurable. So with variables, it was always unclear whether what does this variable do, what does this variable do. So now they have published it in a way that it's supposed to be a template. This is GitLab Cloud. Or I think it's on the latest version of GitLab. If you update in-house also, you can update. Not sure. We are using SaaS, but I think if you update, this feature should be available there as well. It's very cool. We are building our entire CI/CD with components now. Anyone else wants to share anything? All right, then we move to the next. Thanks, guys.
Thank you, sir. Good. Thanks. May I call upon Ahmad Zidane on stage? Where have you been, bro?
I think the front row.
30 minutes. 10 minutes. The timer for 30 minutes.
Have you used the clicker? No, I didn't. Might have to.
Hey guys. Hello. Hello. Hey guys, hello. Are here? Are you guys here? Yes. Okay, that's good. You guys are here? This corner? Do you want to decide here? Ellie, are you there? Okay, so hi guys, how are you doing? That's kind of end of the day. I know everybody wants to sleep. Me too. And I know you guys are hungry as well. Before we jump into the observability. Yeah, today is a kind of big topic. A lot of people are suffering from it. I was the first one to suffer from it, but I decided to let's solve that problem and give you guys this talk. Guys, it's a bag. Can you guys hear me? Hello? Hi? No one in white t-shirt? Okay. Sounds good. It's okay. We missed each other, but let's keep that area focused. If you guys want to have chat, since we have some area outside there, it's good to chat with your friend, right? Because we are missing each other. Maybe we can discuss our personal things outside. Okay? Can we agree on that, guys? Yeah, cool. So, yeah, my name is Dan. I guess most of you guys know me. I guess, hopefully. Yeah, I'm a database builder. Actually spent my 5 years of my life as a software engineer, doing software engineering stuff. And in the last 6 years, I was SRE, so focused only on doing SRE things. And yeah, so this is my LinkedIn, my Twitter. If you guys want to reach out anytime, you want to ask any question, I'm happy to talk to me. And I have only 25 minutes. I need to go through that. Thanks. So again. Yeah, so we need to go through that 30 minutes or 25 minutes. So I need you guys to focus so we can do it quick when we go home and we don't do it just. Yeah, so for our slide today, what we're going to discuss. We're going to discuss why serverless observability matters, review the current monitoring and the gaps, we see the challenges, and then we move to open telemetry extension, collective extension, and then we move to some architecture, and then we go demo live, see how it works in the real life. Yeah, why observability matters for serverless? You guys, can anybody guess? Give you 1 minute. Guess. Why observability matters? Serverless. Yeah, absolutely. That's true. What else, guys? Yeah, absolutely. Peace of mind. Yeah, that's a good one. Money. Money, yes, absolutely. You're all for money. You want to say something? Okay. You say something? The question was how is your serverless tool sending you metrics and uploading your data to your agents or whatever?
Yeah, that's what we were going to discover.
Sorry.
Okay, so serverless quickly. Yeah, many of you know that, so I'll go through that quickly. We need to identify the performance issue, right? We always work for something big. We need to make sure it's performing and so on. We need to have error detection, so we don't need to have the customer complaint. We need to go through that from some error detection and reporting and so on. We're optimizing resource. Sometimes because we are using serverless, it doesn't mean like we just give up, or we don't need to manage the server anymore, and that's it, right? We can optimize that and we save some cost. Gain insights about your application behavior. Lambda behavior itself is weird, so you need to understand what is you need to care about and what is by default there and so on, right? And that's not something easy to do. And yeah, at the end of the day, we do everything, so we can get alert, and then we look into the issue,
find it fast and fix it, right? That's why observability matters for serverless. Yeah, so the current thing, the current monitoring, for the modern application, it doesn't matter, right? We have a server always running, we have the agent, we put the agent there, we put it there, and it's always up and running, and we send it to CloudWatch or X-Ray, or any backend. So OpenTrinity can support any backend, right? But serverless and Lambda, there is no server. Where are we going to put the agent, right? One is the question here, where are we going to put the agent if there is no server? And really, it's a serverless. And there's many things behind the scene when it happens, when the client comes, the Lambda will work and do its magic to do the server, the container, and everything will be up and running for us, right? So the current monitoring, we have no choice to use it. We have CloudWatch, logs and metrics give us some lot of logs for one request, which is kind of, I'm gonna get lost when something goes wrong, looking into that matrix, looking into that logs. Even if we have the X-ray SDK, we implement the SDK inside, we get some traces, right? But the traces will be in one way and the logs and matrix in another way, and they are not correlated. And then there is some third-party agents and trappers that we can use as well, but that also is another challenge. So there are 4 main challenges. I'll go through them quickly before we can see the observability and how it will do it for us. So the first one is cold start latency. In Lambda is actually, you don't pay anything until some customer comes and do request for Lambda, and then your Lambda will start to do the server, initialize the code, and do that thing for you. That thing called cold start, right? And you cannot differentiate between your cold start and your logic, so you are lost there. So if you look into that log, that's the report that's given to you. It's saying it's 598 at the end of the log request give you that report, right? Doesn't mean the 598 is your logic latency or your logic response time, because you have something called cold start, which is out of your hand, and that's how Lambda works, right? So that's the first challenge. We need to differentiate between our logic and the cold start latency. The second thing is distributed tracing. When we need distributed tracing, you have many lambdas calling each other. We need to correlate that with the logs and matrix. As well as the other thing is when you have the SQS event bridge. Most likely, if you are using Lambda, you will be event-driven architecture, right? So you need to build something in SQS or SNS, and this thing needs to be tracked to other services or other Lambda functions, right? That thing will be lost if you are not doing it correct. You can add it in every application request to accept the header that comes from SQS in different way, but this is a manual work and a lot of work to do that to achieve the full things, right? So that's how the AWS SDK is working. The other challenges, as I did mention, is data silos. You have the logs somewhere, you have the matrix somewhere, you have the traces somewhere. So you cannot go directly and find where is the issue and identify that fast, right? Yeah, and of course, the overhead cost. If you are using, for example, Agent Rubber, third-party thing, you're gonna have to go through the internet, and to go through the internet is egress cost, right? You need to pay for that. So yeah, that's the 4 key challenges. There's other limitation, I didn't mention it. Like if you are using the SDK, the AWS SDK, there is a limit that has been set, a sampling rate, it's fixed that you cannot change it. So fixed sampling rate comes with the SDK, you cannot change it, it's not flexible. And sometimes you're going to lose what you want. And many other challenges, but not going through them today. now how the OpenTelemetry extension layer will solve that problem. We understand we have lambda serverless, we cannot control, we cannot have agent inside, we cannot SSH, we cannot do anything with the serverless. We cannot have visibility for it, right? We have four main challenges. We need to differentiate between the cold start latency and our logic latency. We need also to have the propagation between all of our services, even if it goes to SQS and so on. And the third one was cost perspective. We need to save cost when we talk about telemetry and observability. So the OpenTelemetry extension is working actually with two extensions. The first one is language specific layer. So without changing any code, anything from your logic, anything from your code, this out of the box language specific layer, you need to attach it to your lambda function, and it will start to get all the logs, matrix, traces from your lambda function, and then it's going to send it to the collector. And all of them is working with the lambda extension API. Who knows what is lambda extension API? Yeah, please go ahead. What is it? Down here. Okay, so Ravi. Did you know? Okay. So Ravi is AWS community builder and he's specialist in lambda function serverless. So you're supposed to know it. Alright, so consider it is out of the box. It's not inside your logic, but it's extension for your lambda function. You can have something like collector extension to be there, but it's out of your code, right? And yeah, so well, once your lambda function is invoked, and then your code will be initialized, the language specific layer will work, get an instrumentation, it will send it to localhost, which is inside the collector. The collector will open, will listen on localhost. Then all your signal or instrumentation, you can send it to X-Ray or CloudWatch. And of course, you can do it with any other backend. But that design itself, it doesn't go outside of AWS. So you don't pay for the egress cost. Everything is local, and you are good to go, right? And without code change. The most important thing is you don't need to change your code. Okay, so we will go through the quick architecture and workflow. After this, we'll go through the demo quickly. We have like that. So you have user, right? When the user starts to invoke a lambda function, this is the couple of stages will happen like init, and then it will take some time loading all the extensions, loading all your code, initialize your code, and then it will go to the invoke state. And then your instrumentation will come from language specific layer, right? Sent to collector extension, and it will go to your observability stack. But then what if you have two, right? So your extension layer doesn't change. You have that extension layers, you don't change it, and then it's going to send to CloudWatch and X-Ray. But there is something here you guys need to be aware of. We don't have two lambda only, we have many lambdas, right? We have many extensions. And we need to apply something like batching, sampling, and all of this you need to apply it everywhere, which is sometimes you cannot, because the lambda behavior itself is one lambda is running one request, and then this request needs to be fired directly to go to your observability stack. So how we can achieve this? We can just have another standalone collector, which can be deployed in EC2 or anywhere, right? That standalone collector can have all of your logic, like the sampling rate, the patch, the trial, and so on, right? And then it can send to your observability stack. So what other benefits that I get if I have like the collector, standalone collectors? First of all, it's a vendor agnostic. So you have the All configuration you can send it to AWS, you can send it outside of AWS. The other thing is it's resilient. It has all the logic like retries. You have your queue. If it's failed to send to the backend, you can retry it. You have your fetch. You have your sampling. You have all of that logic, right? And then it's going to be centralized configuration. You don't need to configure that everywhere. It's a centralized way you can configure it. And protocol translation, it's always will be like open-friendly. Tomorrow, if with any other protocol, you change it from one place, which is the centralized collection system. And of course, it reduces the code stack. That's a big problem, but that also can help with that. Yeah, so enough theory. Let's see that demo. Take 5 minutes demo. Can you guys hear me? Was that mic? Cool. So I'll just show you what I have first, and then I will go through the steps to achieve that. First thing, I have here my 2 Lambda functions running. They are in Python. And if I go to Lambda function 1, then I just need to test it and see how it goes. Just quickly. This one is invoking the service. There is a couple of layers will happen, like initialize everything, extensions, and then running the server in a sandbox container, and then start with my code. The first time should take time, because that's until your server is ready and up, right? Second time should be faster. Hopefully. Yeah, it's fast, right? Third time should be the same as second time, it's fast also. And we send one more time, just to make sure that we are resilient. Then if you go to CloudWatch, just refresh that part, and I will see that, okay, my instrumentation is coming. See, I have here last 5 minutes couple of requests. That's the this 5 minutes. Can I see the screen? Yeah, cool. So let's take for example that one. So that one. Okay, so let me just give it a word, say, 15 minutes, 5 minutes. Then I have that thing. And during testing, how many resources we pass? 4? 4? Nothing like that. Okay. That's 1 minute. So this should be it, right? Yeah, I think that's 12 seconds at the bottom one is the one that we should. Hey, so what do we have here? Just make it 1 minute. 10 minutes there. Okay, so I'll see that real quick. What do we have here? We have our client, which was me, right? I send the request. Request will come to this function first. This function will call function 2. That part is not clear, right? Because we have function 2 and function 2. What is this and what is this? That actually what is this is the bus that Lambda is taking to do its magic. And this is my logic bus, which is what I have written. So what I have written, my function 2 is calling get request with the HTTP request, and then it's calling S3. It's calling something from S3, right? The other one is the magic that Lambda is doing, right? I'm showing you that. So that's the thing. The first thing, this is not the first request. So I went back to the first request, we're going to see the init, invocation, and overhead. That's the magic behind Lambda, how Lambda actually works. So this is the cold start. So I'm able to isolate that cold start latency from my logic latency. So now I can have the logic latency only here. And I can decide, okay, that's okay, not okay. I can do whatever I want from here because I have full visibility, right? Let me just go through what I have, and then I explain some code. Then we wrap up. Okay, so that's my OTL demo function one. It has two extension layers. As we did mention, we have two layers, right? Language specific layer. The other one is the collector extension layer. What is the language specific layer doing? Language specific layer. Yeah, so auto instrument my lambda function. That's how the auto instrumentation works, right? And what is the collector extension doing?
Well, basically, it's collecting from multiple numbers. You have multiple numbers.
Right. What else it will do?
Send the logs or metrics to your standalone.
Yeah, that's cool. Thank you. That's correct. So the extension layer do auto instrumentation for my code, right? And the collector layer will be able to receive my instrumentation and do everything and send it to my backend. My backend here is the X-ray CloudWatch, right? Yeah, let me show you some code. The other one also does the same, but I have here some different things. You guys have seen any thing weird in my tracing here in this map? Look aside for whoever find it. Look aside. So have you guys seen anything weird here? I have two functions. They're supposed to behave the same, right? So what is different here? Okay, because I don't have time, I'll just answer it. Function 1 doesn't have the magic from lambda, right? It has only my business logic, which is going here. Function 2, it has the path from the magic that happened behind the scene from lambda, which is the cold start. Why is that? Any guess? Why is that? How we can achieve this? Alright, let me show you my code. First of all, I'll show you lambda 2. This is the function 2, right? It has the same thing. 2 layers, one function logic, and that's it. So let me show you the code quickly, tell you what is the difference between that. Okay, and then my 5 minutes come back. It's 5 minutes. Okay, I'll just submit it and then my the second function, I didn't do any instrumentation. It's auto instrumentation only. The auto instrumentation can differentiate between the logic that I want and the actual logic that comes from the magic behind the lambda, right? That can do from auto instrumentation. Second one, I don't want to see the magic of lambda anymore. I want to see my magic only, right? So I just do manual instrumentation. So I instrument only the things that I need inside my code, and that's how to show it like this. You guys got that? So that's how. Got question? No question? Okay, I guess my things will not work. I have the code, but I can show you the code here, no problem. So I can show you the code here directly from here. So lambda2 or the function 2, if you look here, it's normal thing, very basic function. I didn't add any magic as the things that we all write, right? It's a Python code, and I do some look and request HTTP, and then I'm calling HTTP to get some back. That's very normal function. I didn't do anything, only attached the two-layer to it, and it works fine. The second thing, which is lambda2, lambda1. Lambda1 is having the manual instrumentation, right? So the manual instrumentation, you can here see that I'm using the OpenTelemetry SDK, and I want that trace. So the function1 handler is the one that I'm interested with, which is the one that you can see it here in our the function1 called the function1 handler. I have two back. Function1 handler, and this one also is another span that I have added. That's the second one. When I have this function, I also start with another one, which is calling function2. That's the two things that I am interested in when I do my instrumentation for that. That's how you can control it from manual instrumentation. But auto instrumentation is cool, it's nice, but it also gives you more visibility about the cold start one. And you can just ignore it if you don't want, because you have no control there. And if you see like the cold start, there is a lot of mechanisms to get rid of the cold start problem and to keep your function working forward. There is a couple of other things, but it's not our topic today. Yeah. I guess it's not working. Our problem is anyway, let's wrap up. 1 minute. Okay, 1 minute is good. Alright, so some best practices quickly. So best practices. Sampling strategies to balance visibility and cost. Sampling, why do we do sampling? Because we don't need everything, right? Everything is costly. You can give us a lot of cost. I will only some sampling for that to give us visibility about what we have and how to improve it. The other thing is the security intrinsic factors. You need to monitor your extension health. If anything goes wrong, you need to take care of that. Maintain consistency, naming, and metadata. You need to name your service, your requirement, and all this metadata. So yeah, conclusion. Unified telemetry solve ephemeral and start with these challenges. So extension is indicator. Use the extension. Use the SDK for fault control, as I did mention. Manual instrumentation. Give more control, more visibility, and where you're cool. Standalone connector is cool. Use it because you centralize your configuration. You can configure everything from one place. And implement, observe, and iterate. That's what we do, right? Implement, the other one, observe, and iterate. And yeah, thank you guys. I hope that was benefit. Yeah, if you guys have any questions, just don't ask.
Your example for the standalone collector, can you show us the code?
I will watch the code, but my blue thing is not black.
But it's not one, it's a separate code you run. But because it's inside AWS, then there's no.
Yeah, can we go to the diagram for the standalone collector? Yeah, so my question is essentially with the nature of lambdas, right? So lambdas are designed for serverless, nearly limitless scaling, on-demand sort of a thing. So it's to do with how the collector extension layer connects to the standalone collector. So lambdas that are scaling up horizontally pretty aggressively and scaling down. Are we going to hit any kind of like connection limits or connection overheads to the standalone collector? Because usually in our observability stack, we have static pods deployed in Kubernetes or something, and we have a static number of connections that are going into agents or collectors. So how does this scenario cater for that?
Okay, that connector based on my observation and based on my experience, it can handle a lot of requests. It also can queue a lot of requests. It can process that same dispatch. Because the thing that this has advantage is you are not sending records by records anymore. You are collecting from everywhere, batching them, and sending that back. Right? So you are kind of multiplying this resource.
I see. So there's like a persistent connection that's being held between your lambdas, collector extension layer, and standalone collectors per batch request sort of a basis.
No, that's why I should not go in batch and send records by records, right? But this, when you receive everything, and then you are the one who is listening, and then you are just waiting, you are not doing anything, receiving that until I have a batch of them, and then I'm processing them and send them. That's my actual work. But receiving that, I don't do any work until I have the batch. Of course, that can have some problems with delivery if you have a big batch, so you need to choose your configuration right. So any other question, guys? My background? Yeah. There's no background. Background of the laptop will sit that way. The background of my is not background. I'm very curious to see because okay, thank you guys so much, and I hope you got something from me.
Okay, thank you, Zila. That was good. Thank you for finishing it at time. So we have Kahoot just now, right? And it was still going.
Docker swag.
So, ladies and gentlemen, are you guys ready for some Docker swags?
Yes.
So this is the deal. So we will have a Kahoot session where you guys have to compete with each other in a healthy way. So compete with each other. Then if you guys get from probably number 1 to number 3 within the competition, you guys will be getting Docker swags. And I will just explain to you guys how it works, the Docker swag itself. So basically, we don't have a physical swag. We will give you a code. So you redeem the code at Docker's website, and the merchant, the merge itself gets sent to your doorstep. And you don't have to pay a single cent. Docker takes care of everything. All right, please join up, guys.
What's the URL?
Just give me a sec. If you notes. There you go. No swag for us, come on. Come on, guys, join. Wait, bro, that's my name. I think I know who that is. Alright, we have 27 people. Come on, guys, join up, join up. Free Docker swags. So, everyone join? Shall we begin? Shall we begin? Thank you. I need feedback. Still joining. Alright, I'll wait for 1 more minute. Okay, so we will start. 3, 2, and 1. Three, two. Why is observability particularly challenging in serverless environments? They are slower than traditional service? Maybe. They are ephemeral and short-lived. They use too much of memory. They lack access to CloudWatch. Maybe CloudWatch guys. Come on, it's your chance to win. So the answer is the ephemeral and short-lived. 23 people has answered the right answer. So let's see who's number 1 for now. Alright, period. Why you guys put hard names? Alright, next question. Question 2. What is the key limitation of using AWS X-Ray for Lambda observability? It doesn't support error tracing. It cannot trace cold starts. It requires manual SDK instrumentation, or it does not integrate with CloudWatch. Maybe CloudWatch. Alright, the right answer is it requires manual SDK instrumentation. Let's see the podium. Azam is number 1. Oh, I am number 2. Virtually. Alright, third question. Why is cold start latency a challenge in Lambda monitoring? It requires memory allocation. It is hard to distinguish from business logic time. It disables log generation, or it prevents function execution. Maybe function. Lambda, function. Lambda, function. Function, lambda. Alright, the answer is it is hard to distinguish from business logic times. So let's see. Moha is number 1. I forgot, I can't see my name anymore. What issue arises from distributed tracing in an event-driven architecture? Functions don't return values. Event bridge and SQS may drop errors. Memory leaks are more common, or metrics cannot be collected. What do you think? The right answer is event bridge and SQS may drop errors. 13 people answered right. Number 1, Mike. Wow, money line is in. Alright, next. The 5th question. How do data silos affect serverless observability? They increase cold start times. Logs, metrics, and traces are stored in separate systems. They store too many metrics, or they lead to Lambda function duplication. Maybe, I don't know. Alright, the right answer is logs, metrics, and traces are stored in separate systems. And let's see who won it. It's number 1, number 2, number 3. Number 3, Suhaib. Number 2, Mike. Number 1, call me Ma. So can we have these 3 people up in front? Suhaib, Mike, and call me Ma. I want to see the Ma. Alright, so thank you guys. This is all we have for SRE Kuala Lumpur Main Edition. We will see you guys in our next event. Thank you. For people who have not won Dr. Swags, for this round, next round, we will have it every round. Let's take a group picture.
Wait, with the winners.
I think we have one more.
Okay, before that.
Yeah, from Redis, yeah, of course.
Here you go, guys.
Yeah,
There's one more like okay, who's
That's a big one.
It's a big one, yeah. Amit has already shown up the image. Oh, cool. But those were here only, okay?
Yeah, let me do it.
Yeah.
There you go.
Okay, here we
So
go.
we have the spinning wheel, just one shot, right? I think my name is in the cash.
So those who are here, I mean, we'll spin a lucky draw. Those who are here will get it. If not, we'll spin again.
Okay.
Right?
Yep.
Yeah. Okay. Go ahead. Let's do. Nice. Is Naz here? Oh, yeah, it's all here. Oh, guys, pictures. Okay, we have one more back, no?
That's it, I guess. We have one. No. Thank you, guys.
Thank you, guys. Thank you, Kenneth. Thank you. Good night, guys. Bye. Yeah, we'll just take one group picture before you guys leave. One group picture. Yeah, can you guys come forward? One group picture, please. Huh?
Want to take the photo? Oh no, I think someone will.
No, he told me to take it. You take it.